In this video, we're going to examine how we can identify the domain and range for different functions and relations in various representations, and how we can identify that domain and range in both set notation and interval notation. And this is going to come back to our work with inequalities from our last unit. So the first type of relation that we're going to look at is just a set of ordered pairs. And again, like we said in the last lesson, we always want to remember that domain is x values and range is y. This is the absolute most important takeaway from this lesson, because if you flip those, you're going to have a lot of problems. So if I'm given a set of ordered pairs, remember that my domain is my x values, so we can go through, identify our x and our y coordinates. And so my domain is going to be 2, -4, 0, and -2, and we always put those in order from least to greatest. And my range will be the y values, so -3, 6, 5, and -2. And we put those in order. And now we want to graph those on the coordinate plane. So we just plot each point. We have 2, -3. We have -4, 6, 0, 5, and -2, -2. And notice how my domain and range are both just individual numbers. There's no inequality here, there's no range of values. That's because we can only use the numbers from the ordered pairs we were given. So if we were going backwards and going from the graph to the domain and range, my domain and range would just be that set of values. And if we look at our domain, we see that we have 4 numbers, same as our range, so this is a function, and it would pass that vertical line test if I were to draw a vertical line through each point. Go ahead, pause the video, and see if you can identify the domain and range of this relation. Alright, so if we look at this, we have a domain when we simplify it down of -3, -1, and 0, -4, -2, and 2, and this is what our graph looks like. Now for this one, we can't use our trick of same number of values of domain and range to see whether it's a function, because we had some duplicates in both the domain and the range. So I want to check out my x coordinates here. We have -3 and -3. And they go with different y values, so this one is not a function, and it would fail our vertical line test if we put that in right here. Alright, so this is where we get to the good stuff. I'm going to find the domain and range from a graph. And again, when we talk about our domain, we're talking about our x values. So if I look at this ellipse here, we're going to pretend that this extends all the way through to -4 there. I want to think about my range of x values. So if I wanted to shade in all of the x values that are included in this graph, we have everything from -4, we keep going, up to 3, because all of these x values are included. So my domain, if I want to put it in step builder notation, is going to be the values of x, such that, and then x lives between -4 and 3. And we use the inclusive inequalities there because we have points on either end of our ellipse that are included in that graph. If I wanted to write the interval notation, we would have a square bracket, we would have -4 and +3 with another square bracket. So we can erase this, and now we can look at our range. When we talk about range, now we're going to look at the y values, and we're going to do the same thing. We're going to think about what y values do we have in the graph. So this goes from, we'll say, maybe this is -1 and 3/4, and then maybe this is +1 and 3/4. So we have everything, oops, not down there, everything here. Oh, I turned my tablet. Everything here, we have everything higher, everything up, 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 and then we stop at 1 3/4. So in Step Builder, my y values run from -1 and 3/4, inclusive again, to +1 and 3/4. And if we put it in interval, again we're going to use the brackets. So we have -1 and 3/4 and +1 and 3/4. There we go. It's a little sloppy there. Sorry about that. So always think about what values are included. My y values, I run from that -1 and 3/4. I have all of these y values. We're going up, going up, going up, and then we stop. We don't have anything higher than that. So if we wanted to draw a line here, my y values stop right at these 2 lines. And that's how we kind of fill in our inequality. If we look at this next graph, this is a graph of a line, and we have 2 arrows on the end. Those arrows indicate that that graph keeps going in either direction. So that means I'm not limited to what I see on the graph. As my line goes, I'm going to keep hitting all of my x values out this way. So we're going to keep going, keep going, keep going, keep going, and out this way to positive infinity. Same as we go to the left. We're going to keep going, keep going, keep going, keep going, all the way out to negative infinity. So my domain is going to be all real numbers. This is a linear function again because it points a straight line for all the points. And a linear function is always going to have the same domain. And we're going to have this for our interval. If we talk about the range of this function, we'll see that it works out very similarly to the domain. As my function continues to decrease down this way, we're going to hit all of these y values. And as we increase to the right, we're going to hit everything up here. So we increase towards positive infinity and decrease towards negative infinity. So for my range, I'm going to write the same as my domain, except we're going to use y now, because we're talking about y values. And then my interval will be the same. Now take a look at this graph and see how it's different than the last one that we looked at. Instead of arrows, now I have points on either end of the graph. Think back to our work with circles and inequalities. When we had closed circle, that means that this is included. When we had the open circle, that meant that it was excluded. So instead of going on infinitely in either direction, now we're going to have succinct cutoff points, and we may or may not include them depending on what part of the graph we're talking about. So for my domain, I have -5 here, but it's not included, and we go all the way up to 0, and 0 is included. So if I think about my domain, I'm talking about x values that live between -5 and 0, and x is less than or equal to 0, but just greater than -5 because we have that open circle. We can do the same thing when we look at the range. I have this closed circle here at -4, and we keep going up, 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 until I have that open circle at my y value of 5. So if I drew in kind of barriers for my range, I would cut off at 5, and I would cut off at -4. I don't include anything outside those two lines. So my range is going to be the values of y that live between -4 and +5, and y is greater than or equal to -4 and strictly less than 5. Go ahead, pause the video, and see if you can find the domain and range of the function on the right. Alright, so for this graph, we have two closed circles. Woo! Pen is going crazy. Two closed circles on either side. Let me get rid of that. Woo. So we are going to have inclusive inequalities when we write our domain. And then as we look at those x values, we go from -5 up to +4. So we have our domain here. Oh, and I forgot to add our interval notation for both of these, so you can put that in real quick. So because it's inclusive, we're going to have -5 to 4. And then for our range, our lowest y value is -3, and we have everything up to and including +4. So my range in interval notation would be brackets with -3 and +4. Alright, pause the video and see if you can identify the domain and range for each of these functions. Alright, so if we look at our function on the left, for our domain, as this function continues to grow, and this is the absolute value function, that v is going to get wider and wider and wider. So I'm going to hit all of the negative x values and all of the positive x values. So my domain is all real numbers, my interval -infinity to +infinity. If I talk about my range and I look at the graph, I see that I don't have any points on the graph below 0. So my range starts at 0, and then again, as this function expands, it's going to continue moving upwards. So we go from 0 to infinity, which would be my interval here, and then my inequality would just be y is greater than or equal to 0. For the second graph, this is our cubic function, and as this graph continues to grow, either up or down, it's going to continually get wider, which means again, like this first graph, we're going to hit all those x values. So my domain is all real numbers, my interval -infinity to +infinity. For my range, obviously we're shooting up and we're shooting down, so we're going to hit all of those values as well. So we have our all real numbers and our -infinity to +infinity. Now, we're not always going to have graphs to look at. Sometimes we're going to be given the rules of a function. We can use our graphing calculator to give us a picture and see what these graphs look like to help us find our domain and range. So remember that whenever we want to graph a function, we're going to go to that y equals screen on our calculator. So we click y equals, make sure there's nothing in there that we don't want, and remember that f of x can be replaced with y. So instead of f of x equals negative 2x minus 5, we'd have y equals negative 2x minus 5. Make sure for that first negative you use the negative button, and for a minus you use the minus. The two symbols here should be different. Now if we go to graph this, we can see this line extending from quadrant 2 down into quadrant 4, and even though our screen cuts off, we know that that line extends in both directions. So I'm going to hit all those negative x values as well as all the positive x values. So my domain is going to be all real numbers again. So we have the values of x such that x is an element in the real number system, and for interval notation we would have our infinities. If we look at our range, we're going the same kind of idea. We keep going up and we keep going down. So my range is also going to be all real numbers. And remember, for range, we use the variable y. But my interval remains the same. If we look at our second function, this one's going to look a little bit different because we have that x squared term in there. So I go back to y equals. I'm going to clear this out, and we type in our function x squared plus 4x plus 4. And now when I graph this, I can see that we've definitely got a different domain and range here going on. If we start with our domain, as this graph, this is called a parabola, extends to the left and right, it's going to keep getting wider. So my domain is going to be all real numbers again. So we have the same as the other one. But now we need to think about our range. If I look at this graph, I see that it has a definitive bottom point. There are no values beneath this point. So we need to figure out what that bottom point is. The way that you can do this on your calculator is to find the minimum. In order to do this, we're going to hit second, and we'll clear our key space here out so you can see that. We're going to hit second, trace to activate that calc menu, and we want option 3, which is the minimum. We only have to hit it once. Clear that out. We'll delete that. Didn't know you could type that in. So, to get our minimum in, oh, it looks like we double clicked, so we're going to have to start over again. We'll just hit second quit. We'll come back to our graph. My apologies there. I'll clear this out. We hit second, trace. We want the minimum. And now it asks for this left bound. This means that I want to be to the left of that bottom point. So I just use the right and left arrows to move around. We get to a point that we like. As soon as we're sure we're to the left, we hit enter. Now it asks for the right bound, so I move to the right of that bottom point. And as soon as I'm sure that I'm to the right, I hit enter again. And again, it'll ask if you want to guess. I always skip this step. And it'll give me that my minimum is at the point -2, 0. So if this point has a y coordinate of 0, that means that the smallest y value I have is 0. And this function keeps moving up in either direction. So we're going to go from 0 to positive infinity for my interval. And now we're going to include the square bracket, because that point is included in our graph. So we have 0 to infinity. And my range is the values of y such that y is greater than or equal to 0. So anytime you're given a function rule and you're asked to find the domain and range, plug it into the graphing calculator so you can get a picture of what it looks like. Now for the last one, the SOL likes to ask about domain and range because they like to know what you know about functions. So here we have a graph. We have a couple different points on the graph. We have 4 different values, and we need to identify the range. So range is the y values. So here for this point, my y value is 0. For this one, my y value is -4. Here we have a y value of 2. And here we have a y value of 4. If I look at my answer choices, my first one is from -3 to 3, and this one they're trying to trick me with my x coordinates because I have x coordinates at -3 and 3. So that one's out. Same thing here, they're giving me all those x coordinates again. So don't be fooled. These would be domain answers. But we are looking for the range. That's why it's important to read carefully and know the difference between the x and y coordinates. Now we have to decide between these two. If I look at this graph, this is just one set of 4 points. So that means I can only go based off of those 4 points. This is what we call a discrete graph. If the dots were all connected, it would be called a continuous graph because it continues from left to right. If I look at this inequality, this says that the values of y are between -4 and +4. So numbers like -1, +1, and 2 would all be valid answers for y. Except when I look at my graph, this way. If we did -1, 1, and 2, 2 works, but 3 does not. They all work for that inequality, but they're not part of my range. So I can't include them, so I don't want this inequality. If it's a discrete graph, we can only go with the information that's actually plotted in the coordinate plane, and so we have to go with these individual values.